Welcome. In this video, we'll talk about databases. So what are databases? They're basically an organized collection of data for one or more uses that are in digital form. Databases are actually one of the most popular information storage and retrieval methods, and they're used in many domains such as financial, manufacturing, business, personal records, things like that. So early databases, and we're talking about, sort of the 50s and 60s over here, they were methods to keep track of individual records. So this is a popular model that was used was known as the navigational model, in which you have a record that consists of multiple fields, and the database basically kept track of pointers that had, these locations of the next, file record or the next record in the database. So these systems were used to actually keep track of records on punch cards and tape. The major revolution in databases came with the advent of the relational model. It was based on this idea of relational or tuple calculus, and the primary inventor of the relational model was Edgar F. Codd, and one of the first systems to actually use the relational database model was the IBM System R. The main idea in the relational model is to separate the data model and its associated operations. In the navigational model, you have these pointers between records, but if you wanted to access the data in some other form, you still needed to go through these individual pointers. Now, in the relational model, the data model is captured in a form known as the schema. So here we have the schema for a database system that keeps track of tweets as well as the followers graph for a system like Twitter. A schema instance consists of tables that follow the schema. So for example, the blue schema for the table users has an instance here with two rows. Similarly, tweets we have two rows, and for following we have two rows. So here we have a clean separation of the data model, which is expressed as the schema, as well as an instance of the schema, which is the actual data stored in the database. So the relational model basically led to the advent of relational database management systems, or RDBMSs. And whenever you think about a database, this is sort of what comes to mind. You have multiple vendors, you have both commercial and open source products in this domain, like our Oracles and Microsoft SQL, as well as the Postgres and MySQL databases. So the relational database system has been the canonical database system for many decades. When companies sort of hit some of the limitations of relational databases, these were the companies that were working in internet services at internet scale and beyond. And this is sort of in the early 2000s. So there are some scaling limitations with RDBMSs. They are basically, many of these systems have old proprietary code bases and tend to have, some amount of code rot. So their performance may not be as great at scale. RDBMSs are great at something called ACID transactions, and I'll be covering that in detail. And that basically ensures that transactions are atomic, consistent, isolated, and durable. But if you ensure all of those guarantees in your database, then you could affect scalability and performance, as we will see. Many traditional RDBMSs also used complex locking protocols to ensure for data safety, but again, this affects the scalability of the database system. So a number of internet scale companies such as Google and Amazon developed these massively scalable distributed data stores. And by massive scale, we're talking about terabytes, petabytes of data running on clusters that have tens of thousands or even hundreds of thousands of servers. And systems include, Bigtable and DynamoDB. These are some of the first, massively scalable distributed data stores that were sort of discussed in academic papers. Now we have a number of, these systems. These basically abandon, in some sense, SQL and schemas and ACID transactions. So they have different use cases. Many of the systems that you see actually do not even use the sort of the strict SQL style schema that we saw in the previous slide. Instead, they give the ability to have these nested, data models. You might have seen something like this for example, in JSON. So many of these systems allow for, complex nested types that are difficult to express in SQL systems. This class of databases is known as the NoSQL databases, and they've been quite popular for certain types of applications. So the NoSQL data model was useful for different types of applications, but some of the limitations started to emerge of these systems. Users of RDBMS systems sort of asserted that these ACID properties of transactions are actually quite useful, and you can't trust application programmers to get these kind of things right. You have to sort of enforce these rules in the database system. So the performance of RDBMSs and some of these legacy systems that have very old code bases, which is sort of attributed to the main performance limitations that they have, they can be improved if you just simply write efficient database engines from scratch. And some of these systems are very aware. There's a fairly large amount of memory that's available in servers these days. So try to keep as much data in memory as possible, in fact, and you'll be able to have ACID properties, but at scale. These are known as NewSQL systems. And there are a number of different NewSQL systems that have emerged, and many of these have emerged only in the last couple of years. So some of the more famous ones are VaultDB and MemSQL, for example. But NewSQL has become quite popular these days, and they're being used by an increasing number of companies. And this is a space that is constantly changing and evolving. So to recap, these are the main three types of database systems that you need to be aware of. We have the traditional relational databases, we have NoSQL databases, and then we have NewSQL databases.